Click the link in the description to download your own copy of this video's problem. Hey guys, Russ here. Welcome back to another fantastic chemistry video. And today we're going to talk about assigning formal charges to more complicated molecules. Now, let's take a peek at the first one. First thing that screams out to me is the lone pairs are not there. Lone pairs are not there. So we got to put those in. Remember the octet rule. That's going to help you a lot here. Don't just put lone pairs in willy-nilly. Look for the lone pair. Look for the octets. Let's start with the nitrogen over here. 2, 4, 6, 8. This nitrogen already has an octet. Do not give it any more electrons. Once you have an octet, stop. Don't give it any more electrons. No more bonds, no more electrons. Carbon. 1, 2, 4, 6, 8. Carbon doesn't need anything more. Don't touch the carbon either. This carbon, 2, 4, 6, 8, same thing. Leave that carbon alone. This oxygen, 2, 4. That oxygen needs to have 2 more lone pairs to satisfy the octet. 2, 4, 6, 8. How about this oxygen here? 2. It has to have an octet. So start throwing electrons in there. There we go. So now we have the octets satisfied. Let's count formal charge. This nitrogen's in group 15 or 5A. It normally has 5 valence electrons to be normal or neutral. Now it only has 4 single bonds. Remember, single bonds when assigning formal charge count for 1 electron. So the nitrogen here only has 4 valence electrons. Should have 5. So it's got 1 less electron or 1 less negative. That means the nitrogen here is positive. The nitrogen's a cation. Let's go up here. Oxygen normally has 6 electrons. So this one has 2, 4, 5, 6. So that oxygen is actually neutral because this oxygen has 2, 4, and each bond counts for 1, 5, 6. So it should have 6. It does have 6. Neutral. Don't give it a formal charge. This oxygen, 2, 4, 6, and count the bond as 1, 7. Oxygen normally has 6. This one has 7. That one is negative. So we have a cation and an anion in the same molecule. This is known as a Zwitter ion. It's known as a Zwitter ion. Okay? Now, remember, put lone pairs in before you assign charge. Let's go over here. Carbon, 2, 4, 6, 8, octet. Boron, 2, 4, 6, 8, octet. Oxygen, 2, 4, 6. It's missing a lone pair. There you go. I drew it in. Carbon has to have 4 valence electrons to be neutral. 1, 2, 3, 4. Neutral. Oxygen, 1, 2, 3, 4, 5. This oxygen is positive. Oxygen normally has 6 valence electron. This one only has 5. Watch again. 1, 2, 3, 4, 5. 3 bonds in a lone pair is 5 electrons when counting formal charge. Boron, 1, 2, 3, 4. Boron only has 3 valence electrons if it's neutral. This particular boron has 1, 2, 3, 4 bonds. That means the boron is negative. Negative. All right? So that's how you do it. Now, keep that in mind. Some molecules can have plus and a minus in the same ion, if you will. Okay? So I hope you found that video helpful, guys. If you did, slap that like button. Leave a comment down below. Let me know how I'm doing. Let me know what I can do for you to help you in your organic chemistry career. And if you could, share my content with your friends. Let your friends in your class know that I'm out there and that maybe they'll find me helpful as well. And maybe we can get a little team going to help you guys all be successful in organic chemistry. And if you could, please consider subscribing to my YouTube channel. It really does help me out as a creator, and it helps YouTube know that my content is valuable to students. And it really does give me a lot of positive energy to keep making more and more videos for you guys when you guys subscribe. So with that, I want to wish you all good luck and good chemistry. We'll see you soon. Email drbetts@protonmail.com if you would like a copy of every problem in this series.